Hello, welcome to this lesson. In this video, we are going to learn how to determine the length of a curve that is defined by a vector function. So let's say I have this vector function here, which is equal to f of t, g of t, and then h of what? T. Okay, so I have this vector function here where t is defined for the interval t greater than or equal to a, and then less than or equal to what? B. So this is what you have here. Okay, so we're going to learn how to determine the length of an arc or the length of a curve that is defined by this vector function here. So to do this, we are going to rewrite the vector function in a parametric form. Okay, so we're going to have the x component to be equal to f of t, and then the y to be equal to g of t, and then the z to be equal to what? H of t. Okay, so this is in the parametric form. So if you want to find the length of the curve, okay, what we have to do is that we will have to differentiate the vector function. Okay, after differentiating the vector function, then we find the magnitude of it. Then after finding the magnitude, then we integrate over the given interval. Okay, so that's what we are going to do. So differentiating this vector function here, okay, that's r prime of t, then I'm going to have f prime of t, g prime of t, and then h prime of what? T, right? This is what you are going to have. So if you not differentiated it, so after differentiating this, then you come and find the magnitude, which is known as the norm. So we're going to find the norm. Okay, we're going to find the norm after differentiating the vector function. So let's look at that. So the norm will be f prime of t. Okay, let me use square bracket. We're going to have f prime of t, okay, squared, right? All squared plus g prime of t all squared, okay, plus h prime of t, okay, all squared. So this will be the expression for the norm. Then after finding the norm, then what we integrate to get the what arc length. So the arc length L will be equal to the integral for the given interval a to b, okay, of the norm, okay, of the norm. So that will be r of t dt. Okay, this is what you have now. So now you can substitute this expression here into the integral expression. So I'm going to have the integral from a to b for the square root of f prime of t squared, okay, plus g prime of t squared plus h prime of what? T squared. Okay, so this will be the expression to determine the arc length of a vector function, which is defining a curve. So we can do same for three-dimensional case system. Okay, so with this knowledge that we have, let's now try our hands on this example here. This says that we should determine the length of the curve, which is defined by this vector function here on the given interval where t is greater than or equal to 0 and then less than or equal to 2 pi. So that's the interval that we have been given. So let's look at that. So we have this vector function here, which is equal to 2t. We have 3 sine 2t. Okay, 3 sine 2t, and then we have 3 cos 2t. Okay, so this is the vector function we have here. So you have to determine the length of the curve. So the first thing we have to do is to differentiate this vector function here, right? So let's differentiate this vector function. So I'm going to differentiate 2t, and then that'll give me 2. Then I'll differentiate 3 sine 2t. That'll give me 6 cos 2t. right? And then when I differentiate 3 cos 2t, that give me minus 6 sine 2t. Okay, let's take note of this. Okay, so this is the derivative. From here we're going to find the magnitude or the norm. Okay, so let's look at that. So the norm of the derivative, okay, will be equal to the square root. We are going to square the component functions and then add each one of them. So I'm going to have 2 squared plus, then I'm going to have 6 cos 6 cosine of 2t, okay, squared plus, I'm going to have plus minus 6 sine of what, 2t squared. Okay, this is what you have now. So now let's do the simplification here. So 2 squared will give us 4, and then plus, I'm first of all going to do 6 squared, which will give us 36. Let me verify that. Yes, 36. So I'm going to have 36 cos squared 2t. Okay, and then we're going to have plus, when I square the minus 6, I'm going to have 36. So I'm going to have 36 sine squared what, 2t. Okay, this is what you have now. So now let's do some simplification here. So I'm going to factor the common multiple, which is 36 from cos squared 2 theta and sine squared 2 theta. Okay, so I'm going to have 4 plus 36 multiplying cos squared 2 theta. Okay, let me use square bracket here. I'm going to have cos squared 2 2t. Okay, it's 2t and I said theta. Sorry about that. So we're going to have plus sine squared 2t. Okay, this is what you have now. And then from trig identity, you know that cos squared 2t and then sine squared 2t will be equal to 1. Okay, so we're going to have 4 plus 36 multiplying 1. Okay, and then this will be equal to the square root of what? 40, because we're going to add 4 plus what, 36, and then simplifying this, we're going to have what, 2 root 10. So this is the norm that we have now. So we're going to find the length of the curve, which is given as the integral from 0 to 2 pi, okay, of the norm, which is what, 2 root 10 with respect to what, t. So this is what you have now. So let's integrate this. So you just have 2 root 10 here, which is just a constant. So when we do this integration, you are going to, the 2 root 10 will assume the value of this independent variable here, right? So you're going to have 2 root 10 t. This is what you're going to have. Then you're going to be integrating from 0 to what, 2 pi. So now let's do the substitution. So we're going to have 2 root 10 multiplying 2 pi, right, minus 2 root 10 multiplying with 0. So we're going to have the answer to be, we're going to have the answer to be 4 pi root 10. Okay, that'll be the answer. So we are going to have the length of the curve to be equal to 4 pi root 10. So this is how to determine the length of a curve that is defined by a vector function. Thank you very much for watching this video. Please make sure you like and subscribe.